Welcome to the Vector Forum. My name is Helmut Bunge. I'm from Bosch Mobility Sector. And together with my colleague Peter, I want to present you our experiences in our journey of introducing continuous integration, continuous testing in a set of products within our mobility sector.
Yeah, hello. My name is Peter Fröhlich, also from Bosch Mobility, methods and tools responsible in one of the divisions there. And I'm happy to share our experiences with you in this upcoming talk.
Okay, let's dive into the topic. So at Bosch Mobility, we have multiple different software-intense automotive products. We did not count them in detail, but I would say it must be a significant four-digit number of different products, each of them with individual journeys. And our challenge was that we wanted to change the development paradigm from big development and testing campaigns towards a continuous feature flow with small features implemented and continuously testing. And we want to share learnings and success factors with you. So why have we started this journey? Overall, we see that we have big mega trends that drive towards change. Most of them will probably be known to all of you. But what is important for us is that software plays an increasingly important factor to make these solutions become reality. And that strongly affects the way we are developing software. What exactly does this mean for software? What we see is that we have a rising complexity from innovative functions and development standards. In parallel, business needs to increase speed, for example, to react on security issues. The first reaction from our developers was that's two completely contradicting requirements, and it's not possible to bring them together. But well, we tried to face this problem anyways and to develop a deeper understanding. What does speed mean? What does complexity mean? And we were looking at our friends from IT business, and we have learned from them DevOps is a successful approach to develop software closely interlinked with the operations of software. DevOps, that's development and operations. And immediately we got a pushback again from our developers because we as tier one in embedded business are not operating the software. So once again, we triggered our reflection process. What does speed mean? What is really about this speed? And we came across some buzzwords, which we found quite interesting, and where we thought, okay, this can be quite helpful for us in our journey to improve both speed and complexity. Buzzwords like built-in quality or fast feedback for the developers. Again, the big question is, okay, what does this mean and how can we exploit this in our environment, in an environment of tier one business for embedded? So if we look at where we were some years ago, we had an embedded software development lifecycle, which was closely coupled with our hardware releases. So whenever a new hardware was shipped, we came up with one new software, but typically not more frequently. And this approach has some advantages, some strong sides, because once we had fully understood our features, we could achieve a high throughput of these features. And big test campaigns at the end of our development cycle, right before the delivery of our hardware, were efficient, provided we did not find any or at least hardly any errors. But what we also discovered is with increasing complexity of our products and also with a higher degree of changing features, changing requirements, this process becomes fragile because it cannot react on last-minute change requests and can also not react on the need of fixing defects found late in our development phase. So we change our development paradigm And one important step we did is to decouple our software lifecycle from the hardware releases and try to release our software more frequently than the hardware. And that brought us into the DevOps approach, develop software in small increments with continuous and automated testing. So to bring our software into a mode where it's always ready to be released. We call this small batch development. So what we do now is execute our testing campaigns with every code change a developer does. And we make our process more robust towards change of requirement, and we can react quickly on last-minute defect fixes or on last-minute introduction of new requirements. And that we found a very interesting approach. And step by step, we are now migrating all our products into this journey of continuous X. So the first steps into our journey is that we started with an organizational policy which fosters small batch development. And we had a lot of policy elements that help us do this change. As the paradigm change is a challenge for our whole organization, we also established a guiding coalition sharing the same vision. A guiding coalition not only within a set of few developers, but a guiding coalition where we explicitly included management from all levels and our engineers, our experts who were able to shape this journey together with us. In order to help our development teams, we established a self-assessment model and also commonly accepted templates how to set up a journey of continuous integration and continuous testing.
Yeah, then I will look on the next level of what we did. So Helmut was just saying that it was very important on top of the developers being very much interested in this new technology to also bring the guiding coalition, the servant leaders on board of our initiative. And we found it was very helpful for us to use the so-called DORA metrics, so well-known metrics from the DevOps domain, to convey the value of continuous everything to our managers. So to translate what we do into the business value coming out of it. So these metrics, most probably you know them, they are very widespread. For example, the lead time from code commit to successfully running code in production, development frequency, how often do we deploy, mean time to repair or recover, how long does it take to recover from a defect in the operation, and finally the change failure rate, the percentage of deliveries that fail. And these metrics are very valuable because they connect business to development improvements. But still, we also found this is not enough. This is not the ultimate thing, because currently in automotive software, normally you don't see every change every day in the car. That's the one thing. And then still, if you relate to what's happening in the field in the cars, it's not something that every developer can experience every day. So we said, let's take these metrics, but add the developer feedback, the developer value, because this gives us a very quick control loop. And so with these extended frameworks, we started. And on the next slide, we show how we compute these metrics and how we visualize them. In automotive software, you have a very long tool chain, a complicated set of tools. And so it's not easy to measure these metrics, to visualize them and make them suitable for all the stakeholders. So our software community, in a bottom-up approach, they've developed a framework for these measurements, which we call the Flexible Live Data Dashboard Framework. And this framework helps an organization, a project, through the different steps of metrics automation and visualization. So it starts by collecting the data from different databases which are used in the process, like change management tools, software configuration management tools. So the data is dragged out of there and put in a neutral format. Then the next step that is supported by the framework is the data processing. That means the data is connected. For example, traceability relationships in the process, they are visualized in the data and found in the data. And then we have different front ends for the developers, for the different stakeholders, for the visualization. So like dashboards, when overview of the data can be achieved very easily. And also with tools like Splunk, drill down capabilities where we can see maybe a deviation from what we wanted to achieve with the KPI. And then we can look deeper and deeper into the process to find the root of this deviation and to correct it. Yeah, these metrics, these data points are important for the different stakeholders. Now let's look at the different value that we try to create for each of the stakeholder groups. Yeah, this slide visualizes 3 examples of metrics, of indicators with a stakeholder group on each one which has the benefit. So what I said in the introduction, we have, for example, a DORA metric, the lead time, that measures along the whole continuous integration chain from the software commit to the deployment. So it's an end-to-end metric. Very good relation to the business value, to the organization capability of bringing new software quickly. But as I said, less visible for the developer. So it needs some breakdown. You cannot, it's difficult to have a program to optimize the lead time just on that level. So we have to break it down to different parts to really make a difference, to really be able to improve. So on the next level, which is very important, is a team level. So on a team level, maybe we have a little smaller scope. So if it's a development team, could be from a software commit to a system test. So the whole scope of what is automated maybe. And then we measure the team experience. For example, we measure how long does it take to repair the pipeline if there is a software commit which introduces an error until the pipeline will run again. This metric has proven very valuable because somehow it tends to measure the culture or the team spirit, because if the team is really committed to continuous integration already, they will want to have that feedback. They will want to repair the pipeline as quickly as possible. So it's an indicator that helps the team, but it's also an indicator that shows if the team is actively living the CX culture and really getting the valuable feedback from the pipeline. But still, if we go below the team level, still interesting to look at even smaller fractions like the build time. So this could be a smaller scope again. Maybe it's in the case of a syntactic or easy error, it's only defect, it's only from the commit until the build, or maybe it's from the commit until the software test that gives the developer the feedback on the current change that they were doing. And so this is further away from business, of course. You cannot directly say if the company is performing well, but it's very visible for each developer every day. So it's a proxy for developer motivation, maybe, or an indication if they work in an inspiring environment. But it also has a business value in itself, because if this build time is short, it means we can fix the software very often during a day. We can do many cycles, and it will also go up to the next levels. And in the end, we will have a fast lead time if the build time is good. So it's very important to look at this. And so in the next few slides, we will dive a little deeper in some of the components to really improve the developer experience. If we see, for example, something that sounds very technical maybe in the beginning, the triggering of the continuous X pipeline. This is actually an example from very early on in our project that we found that there are two things that could happen when a developer commits software. So on the left side, you see a so-called time-triggered type pipeline. So the different developers in the team, they commit their software, and then there is a kind of a timer, and every so and so many seconds or minutes, the continuous integration pipeline will load the software that is there at that moment in time, build it, test it, and give the feedback. The obvious advantage of this scheme is it is cost efficient, so you don't have to have so much hardware. It's maybe what you start with, what many legacy tools support. The downside is from the view of the developer, as you see in the middle of the left column, suddenly the build fails, and there were, in this example, 4 different commits. So now the team has to search and to analyze which commit caused the defect. Therefore, we found it's much better and supported by the modern tools to have an event-triggered pipeline. So every time I deliver a software, there is a new build process and test process started. That means if it breaks, I immediately know which commit of which developer, which team member caused the outage. So it's more comfort for each developer. It's saving time, and it's the way to go. It means, however, that there is some investment also. For example, we need a scalable infrastructure. We need an infrastructure that allows really these many, many builds with each of the commits, which we want. And if we think further, we cannot spend just infinite money to run slow tools, complicated pipelines all the time. So it triggers what you will see on the next slides, the thought of the relation between architecture and software architecture and continuous integration. So we have to have the pipelines modular. We have to have a software architecture that fits so that the costs of running the pipeline, which is with each developer change, is not too high. And we will break these times that are involved and these investments down a little more. So here we look at an even smaller part of the continuous integration pipeline. It's just the loading and building of the software. So when you look at loading the software, you see this triggering of the pipeline is an important factor I showed on the previous slide. Another factor could be, where is the software stored physically? Do I have it cached somewhere? Do I have to check it out all the time to build it? What do I check out if I check it out? Do I get a lot of documents which have nothing to do with the build? Again, a kind of layout or architecture consideration. If I look at the build step, it's important to have an infrastructure which is fast. During our projects, we found a very important part of this being fast is the I/O performance, because if you compile C programs, you load the same file again and again through the include file structures, for example. And maybe you have a big executable that you have to distribute. The build tools. So of course, having a fast build is a tool issue. So tools which build incrementally help very much, because then they don't have to build everything with every software commit. And finally, the scope of the rebuild. So if there is a software change, the question is, how much of the software needs to get rebuilt? And that's where I will give you the last deep dive, how that really depends on the software architecture. But maybe before we switch to that topic, one thing that we really felt and really enjoyed, this build time optimization. When you first hear it, it sounds maybe boring and very technical, but the opposite was true for our project. So this analysis of build time that brought together really a cross-functional community. So tool people talk to IT people, talk to software architects, talk to software developers. When we sent out the invitations for these events, these communities to analyze this, we got so many replies that our mailbox were really full. So it's really an interesting topic that brings the people together. Much more fun than it sounds here, and a very good effect on the speed of development that you can get out of it. So on the next slide, we see even a little more technical picture of this process. So yeah, why is it that sometimes the software build time for an embedded system is very long? You could say if you talk to people from IT, it's a small software after all. But we have a lot of variation in the software because we often have reuse approaches, and also the software is optimized oftentimes for ROM. So that means the executable has to be small, and we work with a lot of switches and code constructs to remove all the unnecessary part of the software with every build. And that means that the whole software has to be compiled for many changes. And this leads to this long build time because there's so much to build. So the question, if the compiler is running fast, it's just one small part. The big question is, what is the scope of the build that I have to do? And there, the software architects, the experts for the technical architecture of the software, they are extremely helpful because what you see in the middle of these slides, they can come up with modular approaches on the technical side, which allow, for example, to identify core parts of the software where the variation can be taken out. And these parts can then be provided as binary libraries, and the rebuild is saved in that case. If we bring these more decoupled technical structure, we can then map it to tool chains that support it, like the Conan tools, which allow this distributed software build. And we will have a shorter build time. And when we involve the software architects, we will still make sure that it's still also optimized for ROM and now optimized for build time and for improved cooperation, because we have these more distributed and more decoupled software parts. So all in all, that the deep dive story that I told should show that really build time optimization really kicked off when we brought this cross-functional community, and especially the software architects that can make great contributions to that. So, and with this, I want to hand back to Helmut to summarize where we stand with our journey, because of course we're not ready with these topics. We're moving on and try to develop these things further.
Yeah, thank you, Peter. And now we already come to the end of our speech, and just to give you a brief summary of what we have learned on our journey so far. So one key element for success was to involve our important stakeholders to get their buy-in, and especially stakeholders from all levels of hierarchy. Our first focus was on generating quick wins. So bring results to our developers and also to the project teams so that they really feel that the journey gives them a benefit. What we also learned is that automation does not only bring speed for the developers, but it's also a very important step to bring robustness into our development process. And last but not least, the biggest value add that we see is the fast feedback for our developers. We have made very good progress so far, but one aspect of Continuous X is continuous optimization. The journey never ends. Thank you for your attention, and we are now open for your questions to our speech.